One of the major things, I think, of my work over the last several decades is the realization that black holes play a very large part in the evolution of galaxies. And this was not realized 30 years ago. Generally, people thought of massive black holes at the centers of galaxies as being some sort of ornamental bauble that is right at the center, like the fairy on the Christmas tree. But what it is it appears to be, is something that controls the whole evolution of the gas in the galaxy and therefore of the appearance of the galaxy. It affects the star formation and everything else. Black hole produces so much energy and so much momentum in its radiation that it can actually control the whole behavior of the gas in the whole galaxy, or the center of a cluster of galaxies. When I talk about clusters, I'm not talking about the whole cluster, I'm talking about the central 10% of it. But nevertheless, that can be controlled by a black hole at the center of the central galaxy. And the ratio of the size of the region that's being controlled to the size of the black hole is roughly the ratio of the size of the Earth to the size of an orange. So we've got something the size of an orange controlling something the size of the Earth. The mass ratio is 1,000 to 1,000, whereas the mass ratio between the Earth and an orange is much, much larger.
How do black holes occur?
Actually, what happens is you get a star which is more than, say, 30 times the mass of the Sun, evolves, and it lasts only about 1 million years due to fusion of energy, hydrogen to helium to carbon to oxygen and so forth. And you can't go any further than iron and getting energy out of such processes. And eventually the core of the star reaches that state and collapses inwards. Gravity takes over and collapses inwards. And if the star and the core of the star is massive enough, it can collapse down and form a black hole. There's nothing can stop it. So the core of the star, that's the inner few solar masses, collapses inwards, while actually there's an enormous energy release as it collapses inwards. There's a lot of release of gravitational energy, and that's going to fling the rest of the star away, and that's a supernova explosion. And so as far as we know, that's how black holes are formed. Then they grow by either merging with other black holes or by matter falling into them, and they build up like that. There are still puzzles as to how on earth we grow the billion solar mass black holes, because in certain ways there isn't time for them to build up that large, and that's currently a frontier question in astrophysics.
Research at this level seems to most of us almost unreal. How do you approach these cosmological questions?
I feel that serendipity is very important in science. And serendipity in the sense of Pasteur, that chance favours a prepared mind. Okay, and other people have said what's the most exciting thing in science is not saying eureka, but actually saying that's strange. And the thing is, we get lots of that's strange almost every day, and usually it's because somebody's, even yourself, even me, have done something wrong. But sometimes you get things that really don't fit, and that leads to important things. But you need to have your mind prepared to know what's right and what's wrong and what shouldn't be there, to be able to work out what's funny.
What are the big questions today?
There are two very large questions. What is dark matter and what is dark energy? Most of the mass in the universe is actually dark. We don't know what it is. It could be one small particle, it could be lots of particles, it could be lots of primordial black holes. I don't know. We don't know what it is. All we know is we can feel the gravitational effect, but we can't actually detect it. It doesn't interact with electromagnetic radiation or have any electric or magnetic form. There are things we know exist in the universe, or maybe we're wrong about that, maybe they don't exist. But They're really big questions. Most of the matter in the universe is made out of something which doesn't interact with us other than through gravity. What is it? And somebody might tell us next week, they might not tell us for 100 years.